Welcome to this Fixit channel, and today in our Back to Basics we're going to take a look at the Task Manager once again. We did take a look at the Processes tab in the Task Manager, learning a little bit more on how to use it to know when what processes take too much CPU or memory or so on, and how to deal with all the Task Manager processes. Today we're going to take a look at the CPU, or the Central Processing Unit, or what some people call a processor, and check out the information we have in the Task Manager. So head on to the taskbar at the bottom, right click, go into Task Manager. Now if your Task Manager looks something like this, you need to actually click more details at the bottom and go into Performance. Here click CPU, and we're going to examine what information we have here about the CPU on your computer. So CPU, which is the processor, the brain of your computer, it's what makes possible all the running programs. First of all, the information you've got, the type of CPU in your machine. Intel Core i5-3210M on my case, running at maximum speed of 2.5 gigahertz. So that's the information about what type of CPU you have in your computer. You can check it out on the web, see what type of CPU that is. If you of course, Google the information you have there, you'll have lots of information about what it is exactly for a CPU. Then you have a graphical view of real-time activity of your processor in your computer. Sorry. What you don't want here is to have it maxed out all the time. CPU is something that in general you want to have, of course it's going to be used and it's normal, but having it maxed out at 90 to 100% all the time as an adverse effect is that it means that your computer is kind of working too hard. It can happen if you have a very old computer running Windows 10, for example. Core 2 machine running Windows 10 might actually be running your Windows 10 into almost maximum CPU because it is because it's an older CPU. It doesn't isn't as efficient and as fast as today's CPU. So for the same workload, it's going to actually work much harder than, say, my computer. If your CPU is maxed out at 100, for example, or 90% or 80% all the time, even when you're just looking at a desktop, refer back to my first video where I talked about processes, and go to the Processes tab, click CPU, and make sure check out what is actually maxing out your CPU right now. That's one of the things you need to check out, and maybe learn a little more what's really making your computer work so hard. There's an audible way of also noticing your CPU is maxed out. Most of the time, the fans on your PC are going to run full speed. The other information we have here, let's check here at the right side, maximum speed. So this tells you the maximum speed your CPU is set to work at. Now, one of the things you need to know, some of the processors actually have a way of, it's called speed boost. If you have a single thread program, meaning it uses only one of the multiple cores of processors, it can actually go faster than that. So for example, my computer here, maximum speed 2.5, but when I have a single thread software, it sometimes maxes out at 3.03. Because only one core is used, it can actually go a little higher in speed. Sockets, that means the number of sockets or places on your motherboard where you have a processor possibility. So for example, you could have on some PCs 2 sockets or 3 sockets have multiple processors. Here it's one processor on one socket, so one slot on your motherboard. Cores, 2. My i5 has kind of technically call it 2 brains. And so two sets of instructions can be sent simultaneously to have it working faster on the computer. Logical processors. Now that's a way of doing something called hyper-threading. By having logical processors higher, typically it's often twice the number of cores, what happens is that some of the instructions in the CPU clock can sometimes miss out. So for example, say you have, there's like tons and tons of millions of instructions going through right now the processor. But the thing is, there are some moments where that clock speed isn't used at anything. So by having logical processors, you can sometimes insert more information into the clock speed where there are empty spaces where nothing is happening with the CPU. It's just there waiting. So it makes it a little faster. Virtualization. This is, of course, a mode where the CPU can, of course, run virtualized software. L1, L2, and L3 cache. This is basically the amount of memory on the chip itself where instructions can be stored to make things faster. So what it does, it actually checks which instructions your computer is using all the time, and the ones that are always used are stored in that little RAM memory so that it actually can be retrieved faster next time it needs it. Now on the left side here we've got utilization. So this refers to basically the graphic you see at the top. So it means that as you're using a computer, you'll see a percentage of how much utilization. Let's, for example, load Chrome, the Windows Store, Microsoft Edge, and just look at the spikes that it does on the computer. So of course spikes are normal. Having spikes is quite normal. But then you have utilization. So you'll see that depending on what's running on the computer, you have different utilization. So the more software running, of course, the more your CPU is going to be used. Here you see speed, and you might say, well, you said maximum speed is 2.5. Why isn't the computer running at maximum speed? It must be faster. Well, it doesn't need to. Here's the thing. Today's processors, especially the mobile ones in laptops, have what's called dynamic speed. Dynamic speed means that when the computer is using less CPU time, it will slow down the speed of the CPU because it doesn't need to run as fast because the computer ain't really doing that much. So this exists for two reasons. First of all, by using a clock speed that is slower, the computer generates much less heat. And also by using a speed that is slower, battery is saved. So it means that the slower the speed of your processor when in dynamic mode, the more battery life you'll get. So that's why it is set dynamic. And a lot of BIOSes actually let you shut it off if you want and have the computer run at full 2.5 or full speed all the time. Not all BIOSes, but some do. Then you have the processes. So how many software and all sorts of Windows processes are actually running right now through the CPU. And an example of that is if I click Word, you see here it's got 82. Let's click Word. Now when you click Word, I'm at 84. Now you might ask yourself, well, you clicked only one piece of software and you've bumped up 2. That is because Word itself uses a process, but Word might need some other Windows process to work in order for it to execute. So it means that Word takes 2 processes. Say I close Edge. We're at 84. I'm going to close Edge. Here we go. From 84 we go at 80. So Edge was using 4 processes to run at this time. So it means that it needed other processes, including its own, to basically work with the CPU. Then you've got threads and handles. This is the number of instructions and of things happening in the processes while we are using it right now. And finally, we got uptime. Uptime is simply how long has my processor been working? How long has my computer been on? Pretty much. So it tells you that I've been using this computer today for 8 hours now. So I haven't shut it down for 8 hours, and it's been using CPU clock for uptime of 8 hours today. So that's all the information you have. What's the most important for the back to basics is just to check out, make sure that you're not maxed out at 70, 80, 90% all the time. That is something you need to check out unless you have an old machine. Like I told you, old machines, I've got an old Toshiba Core 2 here. When I was on Windows 10, it was pretty much always at 80% in the CPU usage, and you know, it was kind of normal. Windows 10 did ask more on that machine than the Windows 7 that was installed. And basically, if your graphic and your usage looks like this, with little spikes here and there, it's quite alright. And you know what? It does happen that your CPU can be maxed out for a little bit if you watch videos or movies or stuff like that. That is much more intensive, and that can make your CPU go up. The important thing is that it doesn't always stay up, especially when you're just looking at a desktop. If you enjoy my videos, please subscribe to my channel. You'll be informed when new videos are online. Give us a thumbs up if you like the videos. If you have any comments, questions, suggestions, let us know. Hope you enjoyed this little back to basics series on the Task Manager and the information we get from it. And hopefully you will continue following us on the channel.